Guys, I already posted the grade for exam 10. I'm super tired, but I'm going to make this tutorial because I really care. So I'm going to go to India on Christmas Day, and I'm going to return to Brooklyn Tech on January, hopefully January 4, right? So that Friday, I'm not going to give you any test. However, I'm going to give you the same test, this test, exactly this test on January 12th, which is Friday. And if you get 95, once again, I'm making the deal, right? This time you have a long break. You can, that's why I'm making this tutorial. So you get 100, the moment I see everyone gets 100, that would be a Christmas for me, right? So make January 12th also a Christmas day for Mr. Bari if you really care about Mr. Bari, because I'm super tired. I just graded like uh, about 200 exams, enter all those grade. Now I'm going to, only God knows how long it's going to take for me to finish the tutorial, but I'm making this tutorial so that you understand the problem, and I give you the same test on January 12th, right? Give me 95, I'll give you 100. That 100 will replace your exam 7, exam 8, exam 9, and exam 10. So let's go over problem number 1. A 20 kilogram box, let's see, 20 kilogram object, right? Let's use 9.8. So I want to find the weight. What is 196 Newton? So normal force is also 196 Newton. Mu k, I give you 0.3, and mu s, I give you 0.4, right? So quickly find static friction, force of friction, static max, right? And that would be mu s Fn. And mu s, so this is S max would be, mu s is 0.4, 196, and that is 78.4, right, Newton. So what is going on actually? The going on is you have a box, 20 kilogram, applied force is 80 Newton, and maximum static friction possible, right, max is 78.4, right? Since 80 is bigger than 78.4, right, we have to find Fk, which is mu k Fn, which is 0.3 times 196, which is of course 58.8 Newton. Okay, so if you look at the friction graph, over here you have maximum static friction possible, that is 78.4, right? Since applied force is more than this, right, then you have to find the kinetic friction, which is of course 58.8, and object is accelerating, and that's what we are trying to find, acceleration of the object. Acceleration is, so I'm going to write Newton's second law for this. Okay, we're not going to use this one, we're going to use this one, right? Okay, so we're not going to use this one, we're going to, instead of, we're going to write F k, because the object is moving with acceleration 58.8 Newton. Okay, so what does that mean? F is equal to ma. How many forces? You have Fa, you have Ff is ma, right? Fa is 80, Ff is 58.8, 8, m is 20, and acceleration. So acceleration is divided by 20. So acceleration is 1.06 meter per second square. So problem number 3 is very simple. I have two men parted by 10 meter, and I want you to find gravitational force between them. So you're going to use Newton's universal law of gravity. So what is Newton's universal law of gravity? G m1 m2 over r squared, right? So what is Newton constant? Newton constant is 6.67 times 10 raised to negative 11. The mass of man 1 is 100 kilogram. The mass of man 2 is also 100 kilogram. And the distance between them is, of course, the distance between them is 10 squared, right? So you have 6.67 times 10 raised to negative 11. And then you have this cancel, right? And then plus 2, right? So 6.67 times 10 raised to negative 9 Newton. And that is the gravitational force between these two identical men. Question number 4, you know your initial velocity is 20 meter per second, and initial velocity take place at 30-degree angle. I want you to find the x component and y component of the velocity, your vertical component and the horizontal component of the velocity. All right. So velocity is 20 meter per second, 20 meter per second. Has a two component, right? One is the horizontal and one is the vertical. Horizontally you can think of Vx, and vertically you can think of Vy. So what is Vx component of the velocity? Of course 20 cosine 30, which is 17.3 meter per second. And the vertical component is 20 sine 30, which is sine 30 is 0.5, so which is 10 meter per second, right? If you have to draw a diagram, this is how it's going to look like. So your velocity is 20 meter per second at 30 degree with respect to the x or horizontal, right? That's how you're going to be thinking about it. 30 degree with respect to what? You always going to ask. 30 degree with respect to the x-axis counterclockwise. That's how we measure. Number 5, I ask you to find the angle between two vectors. So what angle I am referring to? I'm referring to this angle. Okay, so how can I find this angle? Well, I can use the parallelogram, because this I can turn this one to a parallelogram, right? So now this is a parallelogram, right? Okay, good. The parallelogram or law of parallelogram will allow us to find the angle between this vector and this vector. So let's use the law of parallelogram. So r squared is equal to a squared plus b squared plus 2ab cosine c, right? So r squared is 3.5, of course, 3.5. This is 3.5, by the way. This is 3.5. So 3.5 squared is equal to 20 squared plus 20 squared plus 2 times 20 times 20, of course, cosine c. That's what we're trying to find. 3.5 squared is 12, is equal to 400 plus 400 plus 400, 800 cosine c, right? Now you have 400, 400, 800, 800, 12, so 788, of course, minus, don't forget that because I bring it over here, is equal to 800 cosine c, right? Now I want to write cosine C is equal to negative 788 over 800, right? And that's going to give you cosine C is equal to negative 0.98. Okay, so C is equal to cosine inverse 1. Don't write 0.98. If you do write 0.98, you're not going to find the angle between these two vectors. You have to write a negative 0.98, and that's going to give you the angle between two vectors. And what is the angle between these two vectors? 170. Again, you can use law of parallelogram. You can of course uh, find it using other way which I showed before, but today I'm showing you to find it using a new way, that is law of parallelogram. I also showed it to you yesterday and the day before. Okay, and that takes us problem number 6. I want to find the resultant angle. Before I solve the problem number 6, I wanted to show you how many angle can be possible, right? So let's create a parallelogram. How am I going to create a parallelogram? By using the head and tail. So this is my head and tail. Okay, and of course I'm going to make a copy of this one. All right, so I have head and tail over here, and I have head and tail over here. Great. I have the angle between two vectors here, right? Okay, so the resultant would be from angle between two vectors from two tail to two head, from two tail to two head. Okay, good. So how many angle possible? So few angles should be possible. So this is called angle between head and tail. And this is law of cosine will give you that one. C square is equal to A square plus B square minus 2AB cosine C. All right, law of cosine give you this one. What is this one? This one is angle between two vectors. And parallelogram, I'm going to give you this one. R square is equal to A square plus B square plus 2AB cosine C, right? Okay, and this is called resultant. Which one is called resultant? This one is called resultant. This one is called, this angle is called resultant. And resultant, this angle is resultant angle, right? And resultant angle can be accomplished by tangent inverse y over x, right? And now I'm going to use another way to find the resultant angle. I'm going to move this one. I'm going to move this one. I don't need to have, this makes it so much crowded. So you see this is 60 degree, right? If this is 60 degree, what is this one? This must be 30 degree, right? If this is 30 degree, this is bisector, right? This resultant bisect this parallelogram, right? At the origin. Then this must be 15, right? So the resultant angle, is supposed to be how much? Supposed to be 75. So I'm going to move everything. I'm going to write 75 degree right over here. And to make my resultant super obvious, I definitely can do this one. Take the x of this one. This red vector has an x, right? And this red vector has a y. All right. I can definitely put it this one, and I can remove everything, right? Okay. So this is fine. This is 75. This is resultant. But again, I can put it that way as well. That way is as good as, of course, this one. That way is as good as the other one. Okay, so the resultant angle is 75. Okay, and the next question I'm going to probably ask you, what is the angle between So the problem asking you find the angle between two vectors. If this one is 60, then angle between two vectors would be, of course, 30. And that's it. That's problem number 7. As simple as that. It takes less than probably 30 seconds for you to answer this question. Number 8 asks us to find the angle between head and tail, right? So let's construct a parallelogram so to make it obvious. So this is our parallelogram. Okay, if this is 60, this must be 30, then this must be 150, and 150 is at head and tail. Why? Because this is the tail of vector b. Tail of vector b goes to head of vector a, and so that must be angle at head and tail. All right, 150. Again, this took you probably, I don't know, 10 seconds in the test to answer this question, and that was question number 8. Now we're gonna solve question. Problem number 9. I gave you a displacement vector, and I asked you to find the two perpendicular component of this displacement vector. So one could be, I don't know, one could be 16 and one could be 8. So this one is, let's say this one is 16 Newton, this one is 18 Newton. If this is the case, then you get 17.9. You can create a parallelogram, right? You can create a parallelogram and you find the resultant, and the resultant is 17.9, of course. And so how long is this one? 16. And how long is this one? 8. How do you know? Well, you can use the law of parallelogram. Let's see with the law of parallelogram, I'm going to give you that. So r squared is equal to a squared plus b squared plus 2ab cosine c, right? So r squared is a squared is 16 squared plus 8 squared plus 2, 16 and 8, and cosine 90. Cosine 90 is 0, so this is all 0, right? So r is equal to square root of, right, 16 squared plus 8 squared, and this is 17.9 meter. So problem number 9 is also very straightforward, okay, because cosine 90 makes it Pythagorean theorem. Number 10 is Isaac problem. So Isaac, let's find Isaac, the reaction time. So Isaac drops the ruler to find the reaction time. He drops the ruler and he picks the ruler. He put the two finger and he puts 0 meter over there between the two fingers and release the ruler, and he grabs the ruler at 30 centimeters. Okay, that will give you his reaction time. So d is equal to vit plus half at squared. So this is 0, of course. So t squared is equal to 2d over g. So t squared is equal to 2 times 0.3, 30 centimeter, and this is 10. So t is equal to 0.25, right, second. Okay, now what are we gonna find? We're gonna put him in the car, right, at location 1, location 2, and let's say location 3. Location 1, location 2, location 3, right? At location 1, he sees a man, right? He sees, let's not put this car, not yet. He sees a man, right? He sees a man on the road. Okay? And he decided to slam the brake, right? So over here he see the man. And here he decided to hit the brake. Okay? So this must be, he did not hit the brake here, so this must be constant velocity. How fast he's moving? Well, 40 meters per second, right? How fast he's moving over here when he hit the brake? Again, 40 meters per second, right? How fast he's moving over here? Okay, slower than 40 meters per second, because acceleration would be here -8 because he hit the brake, and acceleration would be 0 over here because it took him some time to make the decision and hit the brake, right? This is constant velocity. This is constant acceleration. Okay. Now, if his car is stopped over here, then the man will, he can save the man. If his car is stopped over here, then he won't be able to save the man. Nevertheless, we try to find the distance from here to where the car come to complete stop, right? Okay, we're gonna put the man later. So velocity final has to be over here 0, right? Because from here the car velocity is no longer 40. Is 30, is 20, is 10, is 5, and is 0. Something like that. Okay. So let's try to find the distance he moved from here to here. So that distance should be VIT plus half AT square, right? And this is 0. So D is 40 times, of course, T is how much? 0.25. All right. So distance he moves is 10 meters, right? This is the distance from here to here. Okay, now we try to find the distance from here to here, right? Okay, that distance we are trying to find. Now VF square, of course, VF square is right here. VF is equal to 0, is equal to VI square plus 2AD. So this is 0, and VI square, of course, this is 40 square plus 2, of course, this is negative 8, and D, right? So D is 100, so 100 meters. So from here to here, from here to here, from here to here is 110 meter, right? 110 meter. The man is only 60 meter away from here to here, okay? So although his car is stopped, right, 110 meter away from where he initially see the man, but he wasn't able to stop the car right before hitting the man, is because probably his reaction time was just too much. If reaction time is 0.25 seconds, that's not good. If his reaction time, next time I ask you what reaction time will allow him to save the man. How about that? Okay. All right. Then now we're going to solve problem number 11. The problem 11, I have two vectors, right? The vector 1 is 90 degree above the x-axis, and vector 2 is 55 degree below the x-axis. Okay, so now if you add them up, what would that be? The angle between two vectors, I'm gonna just have to write 55, of course, below the x-axis. So 55 plus 90 is 145. That's the angle between two vectors. I don't have to put that one. So if I have to draw a, what do you call it, a parallelogram, and this is how I will be drawing it. Okay, and this is the parallelogram, and this is the resultant vector, and that's what we are trying to find. This is, of course, 10 Newton. This is, of course, 20 Newton. Okay, so the resultant is a square plus b square plus 2ab cosine c. This is called law of parallelogram. R square is a square is, of course, 10 square plus 20 square plus 2, 10, 20 cosine 145, right? So that R is 13. So this is 13. So problem 11 is pretty simple, but you can solve it you can solve this problem other way as well. That takes us to problem number 12. 12, two concurrent force, right? So let's say concurrent force A and concurrent force B. This is 3 Newton, and concurrent force B, which is I don't know, is it 3 Newton? I don't know. 3 Newton, and resultant is 5.2 Newton. Okay, so this is X this is I'm trying to draw a parallelogram. So this is a parallelogram, and I'm going to draw a resultant right now from origin. Okay, so this is 5.2. I want you to find this one, x. I gave you this one. This is 30. Did I give you this one? No, I did not give you this one. Head and tail is how much? Head and tail is the hint. Angle between head and tail is 120 degree. I gave you angle between head and tail is 120 degree. So I told you this is 120 degree. So that must be 120 degree. Let me put it away now. So this must be 60 degree. And this must be 60 degree. Then this must be 30 degree. And to find the resultant angle is very easy right now. If this whole thing is 60 degree, then this one has to be 30 degree, 30 plus 30. So the resultant angle is of course 60 degree. Angle between two vectors, is equal to 60 degree. Angle between head and tail is equal to 120 degree. I want you to find, and the resultant is 5.2. Okay, I want you to find the x. Well, it's pretty easy. I gave you everything. Okay, so how can you find it? Let's see. Law of parallelogram. Sure, law of parallelogram will do everything. So r squared is equal to a squared plus b squared plus 2ab cosine c, right? So you have 5.2 squared is equal to, let's say I have the first one, 3 squared, plus I don't have the second one, b squared, plus 2, I have 3, I have b cosine, what is it? The angle between two vectors, I have to use 60, right? Okay, so let's see what are you gonna get. 5.2 squared. 5.2 square would be how much? 27 is equal to 9 plus b square plus 6b cosine 60. So cosine 60 would be 0.5, so half. So this goes to here 3 times. So I have 27 is equal to 9 plus b squared, right, plus 3b, right? So far so good. So 9 comes over here, so this is 18 is equal to b squared plus 3b, right? Okay, this looks like a quadratic formula. So I have 0 is equal to b squared plus 3b minus 18, right? So I have a is equal to 1, b is equal to 3, and c is equal to negative 18. Let's see whether I can use the middle term factoring formula. 16, I think so. So b squared plus 3b minus 18 is equal to 0. So b squared plus 6b minus 3b, yeah, minus 18 is equal to 0. I don't have to do quadratic formula. B factor out, b plus 6 minus 3 factor out b plus 6. Okay, so b minus 3 b plus 6. Of course, this is extraneous root. B is equal to 3. Now we found our x, and x is 3. All right, that was problem number 12. Now let's move to problem number 13. Problem number 13, I ask you to find the angle between head and tail. I gave you the vector A, which is 5, vector B, which is also 5, and resultant 6.9. So let's draw the two vectors. I'm going to draw vector A, which is, of course, 5 Newton, and vector B, which is also vector B, which is also 5 Newton, right? I'm gonna create a parallelogram. So this is gonna be our parallelogram, and this is the vector I want you to find. This is the vector I want to find, because this is head and this is tail, or this is the angle I want to find, not this one, definitely not this one. Okay, if you find this one, then you use r squared is equal to a squared plus b squared, right, plus 2ab cosine c. But we are not finding this one, we are finding this one. So you have to use c squared is equal to a squared plus b squared minus 2ab cosine c. C is, of course, 6.9 squared, 5 squared plus 5 squared minus 2, 5 cosine c. This is 49, this is 50, this is 50, this is 25, this is 25, this is 50 cosine c. All right, so I have c is cosine inverse 1 over 50, and that is 87. So this is 87 degree. Okay, this is probably 93 degree. I did not ask you this one. This is 87 degree. That's what I asked. 14 is the mailman problem. So what is going on? You have a mailman moving north with let's draw nicely. 10 Newton. You can think of this as vector A, or 10 meter, doesn't really matter. Let's call it 10 meter, or just A is 10. And then he moves, he turn around 30 degree angle and moves 20 meters. Okay, so he moves 20 meter at 30 degree angle. This is not, it doesn't look like 30 degree angle. This is more or less look like 30 degree, negative 30 degree, that's what I mean. Okay, so I'm gonna create a parallelogram. To create a parallelogram, I have to create this one, and I have to create this one. So this is our parallelogram, and of course this is 30 degree. So if this is 30 degree, this must be 60 degree, and this is 20. Vector B is 20, and if this is 60 degree, this is 100. This is 120 degree. This one is 120 degree. And let's draw the resultant vector. That's what we are trying to find, resultant vector. We want to try to find the result. This is size of this one we're going to find. So size of this one is what? Parallelogram, because we know the angle between two vectors. So r squared is equal to a squared plus b squared plus 2ab cosine c. So r squared is equal to a squared, of course, 10 squared plus 20 squared, right, plus 2, 10, 20 cosine 120, and that's gonna give you 17.3. So the size of this one is actually 17.3. This is 17.3 meters. This is the resultant. That was 14. Now let's go about 15. 16 is pretty easy. A 10 kilogram book is sitting, 10 kilogram, right? And Isaac is applying, well, what is the weight before that? Let's use 9.8, so 98 Newton. And what is the normal force? We don't know yet because Isaac is applying. Isaac is pulling the box with 90 Newton. So we have to find the normal force. So you know that F is equal to 0. Newton's first law tells us all the forces acting at the y direction is 0. What are the forces? Fn plus Fp minus Fg is equal to 0. So Fn is equal to Fg minus Fp. So Fn is equal to Fg 98 minus Fp 90. So Fn must be 8. Okay, so this is 8 Newton. Normal force is 8 Newton, and that takes us to problem number 6. This is Newton's second law problem. So let's say I have a 10 kilogram object. Force of friction is, of course, 10 Newton. So applied force is much bigger. Why is that? Is because there is acceleration 2 meters per second square, right? So if applied force is not bigger, then there would not be acceleration. So Newton's second law will allow us to solve this problem. Newton's second law tells us all these forces at the x direction is not 0, is ma. Okay, so what is that? Fa minus ff is equal to ma, right? So a is fa minus ff over m. So what is a? Fa is, you don't know. Well, we are actually find fa. Fa is equal to ff, right? ff plus ma. So fa is equal to ff is how much? 10 plus m is 10 times 2. So fa is 30. So this is actually 30 Newton. Okay. So you can 30 minus 10, 20, 20 divided by 10. This is 2. Problem 18 is solved many times. What happened if you have to jump up? You have to crouch. You crouch how long? 0.3 meter, and that send you to the air. Okay, at maximum 10 centimeter. Okay, at max height the velocity is 0. Acceleration is z. Right here velocity is 0 at location A. Acceleration is 0. At location B, velocity we are trying to find. Acceleration we are also trying to find. Okay, so this is the problem. So step 1, Vf squared is equal to Vi squared plus 2Ad, right? At max height, velocity is 0, right? And we are trying to find this velocity. And at max height, acceleration is negative 10. Okay, so velocity is 1.4, right? So now we can find the acceleration. Velocity is 1.4. Now we can find the acceleration. Vf squared is equal to Vi squared plus 2Ad, right? So now Vf is 1.4 square, right? Is equal to Vi is 0, right? Plus 2, acceleration we're trying to find. How long did you accelerate? 0.3. So now velocity is, that's what you're trying to find. I'm sorry, acceleration is, that's what you're trying to find, 3. This acceleration gave rise to this velocity. Okay, now I want you to find now the 80 kilogram man weight. The weight is 800 Newton Fg. That's the earth pulling him. He pulls the earth with the same amount, 800 Newton. Okay, so what is the F push? Is mg plus a. So 80 times g is 10 plus a is 313, which is 1040 Newton. So if that one is 1040 Newton, this one is also 1040 Newton. So what is the net force? F net is F net is 1040, 800 minus 1040, so negative 240. So acceleration is negative 240 divided by 6 times 10 raised to 24, right? So acceleration is negative 4 times 10 raised to negative 23 meter per second square. That is the problem number 18. Now let's go over problem 19. Problem 19, I solved it at least 200 times. You even solve this problem in the lab, right? So problem 19, it doesn't matter if you have a long table and a marble roll on the long table with some velocity, it doesn't really matter. Okay? All right, it doesn't really matter. I ask you to find the impact velocity of this marble, vertical impact velocity. Next time I'm going to ask you the horizontal impact velocity. This time I ask you vertical impact velocity. I did not ask you the horizontal impact velocity. If I did ask you horizontal impact velocity, you need to know that it doesn't matter now how fast or how slow it is rolling, because Vx is, we don't need to know. Vy is 0. Okay, so what is the time? The time is equal to 2d over t. Where did I get it from? D is equal to VAT plus half AT squared. Why this is 0? Because this is Vy. Vy is 0. Okay, and why this is negative 10? Because this is G. Why this is negative 10? Ay is negative 10. So t squared is 20 divided by 10. So t squared is 2. So t is 1.4. So the velocity over here is Vy is equal to Vy is equal to Vi plus At. So Vi is 0. So 10 times what? Negative 10 you can put 1.4. So it's 14 meter per second. So the magnitude of the velocity and the y direction right here is 14 meter per second, right? Very simple problem. Last problem is super easy problem. I ask you to find the acceleration of this box when no friction. Okay. I ask you to find the acceleration when the incline is 20 degrees. So, okay, this is super simple. This is FG parallel, right? FG parallel is mg sine theta. So what are you going to do? You're going to write Newton's second law, because you have to find the acceleration. Make sure you write ma, because there is an acceleration. I ask you to find the acceleration. The box is accelerating. Don't write Newton's first law. Do not write Newton's first law. This is not Newton's first law. It's Newton's second law. What direction? Parallel. Parallel with respect to the box. Okay, so how many forces you see? That you only see one force is mg sine theta, right? Is equal to ma. Cancel. So acceleration is g sine theta. So acceleration is 10 sine 20, and that's gonna give you 3.4, right? Super easy.